Okay, we should be yeah, where is the chat? I don't get this. Maybe I will move this to Twitch. Yeah, this kind of sucks. YouTube sucks for streaming, guys. Delete this. Live on YouTube. Okay. Okay, we good. I think we're good now. Yeah. Okay. Uh, so we got our draft from our code for Code4rena. Okay, so the Code4rena analysis yielded an aggregated total of 19 unique vulnerabilities. Of these vulnerabilities, 10 received a risk rating in the category high and 9 of category medium. Additionally, C4 analysis included 12 reports detailing issues with a risk rating of low severity or non-critical. Okay. Cope. Let's open up our repository. Okay. So this was the repository in scope. Good. C4 assesses the severity of disclosure vulnerabilities based on the three primary risk groups: high, medium, low, non-critical. High level concern from conducting assignments. Malicious input handling, escalation of privileges, arithmetic gas usage. Okay. Design flaw and mismanagement of all licensing leads to double counting collateral ratios and position collaterals entirely with currency. Yeah, so as you can see, most people found this. We did some last minute changes before submitting our repo, before freezing our repo. So yeah, it's a pretty trivial issue. So a lot of people found this due to the inflow management of fault licensing and deploy script. A significant risk exists where collateral can be counted twice. Yeah, so in the previous design, the one we submitted to Code4rena, we had the following logic of counting collateral. So we had vaults which hold exogenous collateral and vaults kerosene which hold kerosene, and you have an add for adding normal collateral and add kerosene for adding vaults with kerosene, and these aren't working correctly, so that's basically what this issue is about. In the new design, We don't have that anymore. In the new design, I'm on the wrong branch. In the new design, we only have vaults. See? So we have one array where we keep track of all the vaults inside your position, which makes it way easier to keep track of things, um, which is nice and a lot easier. Okay, so this was the first one. Um, it also adds so there's also a problem in the deploy script, calls both contracting licensing transaction functions on the wrapped ETH vault, currency manager add. The licensing via the currency manager also has to be done because the wrapped ETH vault will be used by, yeah, so basically the whole system how we kept track of kerosene vaults and normal vaults was something I added last minute, and yeah, it has some pretty basic errors. So we changed that system totally. I think it's a lot nicer now. You only have one function to add collateral and one function to remove collateral, and that's why we don't have these issues anymore. The licensing via the currency manager also has to be done because the word is used here. This can be exploited where users can call both Vault Manager add kerosene and Vault Manager add functions with their ID and their apt. Yeah, so basically you could have added kerosene vaults to your non-kerosene vaults positions, which is obviously a big mistake. Okay, yeah, mitigation, we definitely fix that. Okay, inability to perform partial liquidations allows user position to accrue bad debt in the system. So previously, we had inside the liquidation function, you had to pay off all the debt in order to liquidate. Which obviously, if you have a huge position, this can be an issue. So the recommendation was to do a partial liquidation. Basically, only pay off part of the debt position in order to solve this. Hey, I can't find the report on Code4rena. When will it be published on there? This is the final draft, sir. So very, very soon. This is basically my final review. Okay. So how we solve this, as I've said, is we have the partial liquidation now. This here, where basically, okay, you can pay off a specific amount. You don't have to pay off the whole amount. And but you get rewarded for paying off a larger portion of the debt position. So this is how we incentivize to do the whole thing, but you don't have to. Okay. Proof of concept. Implement a mechanism to allow liquidators to partially liquidate positions. This would also require effective collateral paid out to them based on the amount they cover. Yes. We have this partial liquidation now, and we already did an audit for this as well. So this is definitely the final liquidation version that we're gonna deploy very, very soon. Okay. Attacker can make a zero value deposit call to deny user for redeeming or withdrawing collateral. This is a kind of interesting one because, okay, let's look at deposits, right? the deposit function only increases your collateralization ratio. So my thought was, and how it's done in DYAD version 1 is, if it's only increasing your collateralization ratio, why not let anyone call this? And this is why we have the modifier is valid DNFT here and not is DNFT owner. Is DNFT owner. The problem and the difference between this and V1, let's look at V1 in the deposit function, is we don't have that flash loan protection mechanism anymore. So ID to block of last deposit is basically how we avoid flash loans. We cannot deposit and withdraw in the same block, and we didn't have that in V1. But the problem now is anyone can call this and basically block you from withdrawing. So if I'm a block builder, for example, I could see in the mempool, hey, this guy is trying to withdraw. I'm just gonna deposit with nothing, with zero amount, and that's how I block withdrawals, which could be very bad. So the change here is basically do a DNFT owner in order to make sure that only the owner can deposit. Yeah, exactly. Function deposit uses modifier is valid DNFT instead of his DNFT owner, which allows anyone to call deposit on behalf of any DNFT ID. So I think it's outlined in the mitigation as well. Use modifier is DNFT owner instead of is valid DNFT. Yeah. You know, this is actually like an interesting point in designing smart contracts. I feel like you always want to, if it's beneficial to the user, make it open to anyone, right? For anyone to call it. But the problem is, I guess better to be conservative, and maybe the benefit of opening the function isn't worth it for a very small percentage of a possible exploit that is opened up by this. So I think in the future I'm gonna avoid this, where, for example, if you have a CDP position, I will always gate it by the CDP position owner. Okay. 4. Attacker can front run users withdrawal to make them revert without costs. Users' withdrawals will be prevented from success, and attacker can keep it up without a cost by using a fake vault and a fake token. There is a mechanism for a flash loan protection that saves the current block number in a mapping and then prevents it from withdrawing at the same block. As we can see, this can be called by anyone. The attacker can use this to prevent any withdrawals. Yeah, this should be fixed by changing the modifier. Users withdraw prevented. The attacker can use this to prevent any withdrawals. Yeah, because anyone can call this. You know what? Let's play some. Let's maybe play some music in the background. Some 80s Japanese city pop. Nah, this is too much. Let's play Synthwave. Okay. Consider limiting anyone with any token. Yeah, one mitigation is changing the modifier. Unable to withdraw kerosene from Vault Manager 2 as it expects a Vault Oracle. Yeah, this was a simple mistake from my side where the kerosene. So we have the most interesting feature in this is the kerosene token that we have now, and the kerosene token has a deterministic price. So you know what? Let's open up a terminal. It sucks to look at code this way. Okay, kerosene. Okay, so we have this kerosene token, and kerosene vault. In the kerosene vault, we have a function that calculates this the kerosene price. So what's interesting about kerosene is it's deterministic. So if you compare the vault kerosene to a normal vault, for example a wrapped ETH vault, the wrapped ETH vault calls into an oracle, and the kerosene vault doesn't. It uses a deterministic equation to calculate the kerosene price. So the problem outlined here is we have a function in the vault manager which calls into an oracle and redeem and liquidate. The problem is the kerosene doesn't have an oracle, it doesn't use one, but we have this interface. So what I did is I added a mock oracle to this, which just returns basically 8 decimals, and that's it. So this is the problem outlined here. Given that the value of exogenous and endogenous collateral is calculated differently, it's necessary to handle withdrawals of XR collateral and kerosene differently. It would avoid added complexity to function logic stuff. Yeah. This is obviously, the easy solution was just adding a mock oracle, I think. This is what I did. Okay. User can get their kerosene stuck because of an invalid check on withdrawal. The protocol allows users to deposit both kerosene and non-kerosene collateral from a DYAD. Users should have an equal value of non-kerosene collateral. So users should have 100% non-kerosene and the rest could be kerosene collateral. However, in Vault Manager v2 withdrawal, the protocol allows users to withdraw kerosene and non-kerosene collateral by just passing the corresponding vault. When withdrawing, it checks if the okay. So let's see what the problem was. So basically, when withdrawing this part, if we go back, let's see, yeah. So basically, this part. So how we solve this? I think the withdrawals and redeeming are very nice now. Okay. So basically, what we do in the withdraw function is we check if it's not a flash loan or you didn't deposit in the same block. Then we do the withdrawal, and then we have a function. we have a function called check exo value and collateralization ratio, exogenous value and collateralization ratio. So when we're drawing, we check, is the exogenous value still enough, and is the collateralization ratio enough? So we get both exo value and kilo value. We get the minted DYAD, and obviously this is all after doing the withdrawal here. We check if the exo value is smaller than the minted DYAD, which basically this 100% check. We revert, and then we check for the collateralization ratio as well. This is how we do it now. Missing enough exo value, exo collateral check, liquidate makes the collateral even if okay. Okay, so the problem in the old liquidation mechanism was, and this is again because of the complexity of keeping track of kerosene and non-kerosene collateral. When doing the liquidation, we didn't move over kerosene, which is obviously a mistake. But because we only have this one collateral array now, we also move over the kerosene. So let's look at the liquidate function. As you can see, we have this move, which moves collateral from one DNFT to another. And we do this for all collaterals or collateral types inside your collateral position. So kerosene as well, because kerosene is treated as a normal collateral type. Okay. Users can get their kerosene stock until TVL becomes greater than DYAD supply. Okay, this is a problem we have. That is part of the kerosene calculation. Okay, so you see this? You see how we calculate the numerator? It's TVL minus DYAD supply. So in the first version, the DYAD supply is already there, right? So it would take a long time, or it would take, I don't know, a couple of days to have a TVL again. So this would fail and basically break not break the protocol, but it would break liquidations and stuff. It would break anything that calls into this asset price function, which is bad. But now in V2 it has a new DYAD total supply, so this should be fine. But it's a valid find. Recommended mitigation steps. This is a bit tricky, but I think the most straightforward logical solution would be to block the usage of kerosene vaults until enough users mitigate. Yeah. Okay. Kerosene collateral is not being moved on liquidation, exposing liquidators to loss. Exactly. This is fixed as well. User can get the kerosene stock until okay. Let's see. Yeah. Okay. Flash loan protection mechanism can bypass via self-liquidations. The protocol Protocol includes a flash and flash protection mechanism with the DYAD block of last deposit variable. This value is set to the current block number during the deposit is checked during withdrawal. If the system detects a deposit and withdrawal on the same block, the system reverses the transaction. The issue is that there is another way to move funds around. Yeah, this is a very good point. So we didn't have the flash of protection for the liquidation. We only had it in the deposit, but actually the liquidation sort of is like a deposit for the DNFT that is doing the liquidation because of this move. Basically, this move is like a deposit. So the fix here is to do a last deposit. Basically, you set the last deposit here as well. I just renamed that. So in the old version, it's ID to last deposit. I thought this was a bit long, so now it's just called last deposit. Last deposit. And so we set that to the current block number. Okay. The flash and protection can be bypassed. MEV liquidation must rely on flash nodes to carry out liquidation storage is a very good way to prevent this attack vector making press. Less manipulated is a good way to lower this attack chance. However, the system will still be open to flash node deposit via liquidation. Incorporating a mint fee will also help mitigate this vector since the attacker will have a higher customer with the system. Okay, yeah, we're not gonna do this. We're only gonna set this flash node protection as if it's a deposit. See, if you look at the comment, move X like a deposit, the move reference is this one. Liquidation bonus logic is wrong. Yeah, we overhauled the whole liquidation mechanism now. Totally different. Okay. No incentive to liquidate when CR is less than 1 as assets received smaller than DYAD burned. Well, yeah, this is like a common problem in CDP positions. That's why I don't get why it's a medium really, because okay, if your collateralization ratio drops below 100%, where should your reward come from? So some people are suggesting something like an insurance fund. MakerDAO has something like that. It just sounds incredibly complex. Definitely not gonna do this. And to be honest with you, like we have a minimum collateralization ratio of 150%. If 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 your collateralization ratio drops below 100%, then you know it's a very big issue. Like the drop in ETH price or in the collateral you used. It's just and if it happens, yeah, where's the reward coming from? Just bad data in the system. And sure, you can build something like an insurance fund, but yeah, I don't know. Actually, it would be interesting to look at. I should dive deeper into this. Obviously, I know how liquidations work and other protocols, but I actually not 100% sure how they deal with this issue. Like when it drops below 100%. Upgrading this to medium due to the following: the absence of a mechanism to allow liquidations bad debts. React creates a potential risk for the protocol. I couldn't find in the documentation code that it is an accepted risk based on an intended design. Award kerosene from, yeah, that could be one way. Like we have this kerosene supply, obviously, which could be used as a insurance fund, but you're just just a negative for kerosene holders. So yeah, I don't know. This seems to be a good starting point. LP will be incentivized to liquidate in return they receive kerosene. Then can be sold in the secondary market and reused to mint DYAD. However, consequences of the approach will be taken into account and addressed. For example, circulating will increase, which will influence the price. Yes, exactly. This is a very good point by Kulex here. And I think, to be honest with you, I think this is something you can build around the core smart contracts. Like, you don't necessarily need to implement that in the vault manager itself. Maybe look at the other comments. Infected commented, I believe the other possibility would be based on a debt socialization. Allow liquidator to burn only DYAD equivalent of collateral or accuracy from the bond billing. Yeah, but I feel like a fund balance generated by fees taken from good liquidation to cover for these rare situations is still the best way to go. I really don't like the idea of insurance fund. We would think about the kerosene solution. It could be an interesting approach. Okay. Set unbound the kerosene vault not called during deployment causing rewards and accruing for kerosene value after adding it as a kerosene vault. Set unbound the kerosene vault. We this is also a weird one because I remember, if I remember correctly, in the old deployment script we don't add the bounded kerosene vault. So why we don't add it? Like, I left this comment in just to make it clear that we're gonna do it later, but yeah, you know what? Actually, I'm gonna write this down. M03 medium 3 doesn't make sense to me. Okay. Where's medium 4? Liquidating positions with bounded kerosene could be unprofitable for liquidators. We don't have the bounded kerosene mechanism anymore, so but one solution was when bounded kerosene gets liquidated, we make it unbounded, and bounded and unbounded is basically when it's unbounded, you can withdraw it, but when you bound it, it's not withdrawable. So maybe in the future, if we reintroduce this feature again, we will add this, which would actually be implementable without changing the vault manager itself. We would only need to change the vault. Actually, yeah. Let me write this down. Make okay. M5. No incentive to liquidate small positions because resulting protocol given you on the water. The DYAD protocol allows you to suppose it as little as one way. However, in order to mint the DYAD token, the protocol requires users to have a collateralization ratio of 150% or of liquidity users for the profit they can make. Currently, the DYAD protocol works the value of the DYAD token. If there is no profit to be made, the protocol will be deployed on Ethereum where gas is expensive because the reward money liquidation we receive is low. Yeah, this is a hard one, but like consider setting a minimum amount that users have to deposit before they can mint DYAD. Minimum amount of 5 to 600 should be good. Well, what if the gas prices explode, you know? Then even 5 to 600 is not enough. So this is a tricky one. You know, obviously if the position is too small, technically it's bad debt, but the protocol itself could liquidate it. Again, we could build like a Kersian reward thing around this, but putting in like hard coding in a minimum amount doesn't feel right to me. Really doesn't feel right to me. Okay. M6. Attacker can front run to prevent vaults from being removed. When removing a vault from the DNFT position, the vault must have no assets for that DNFT. This is again the problem because the deposit is permissionless. And actually this is an attack vector in V1. You could be prevented from removing a vault. So yeah, the deposit function is not permissionless anymore. So this is an issue. Test does remove vault. Okay. Allow the NFT owners to remove vault from their DNG position even if it has assets, but have a clear warning that doing so might be... No, actually, this is not the problem. The problem is that you can do some weird things with the liquidation. If you can remove vaults, you can save yourself from being liquidated. That's why we have this. Not big. That's the main reason we are having this. I think this was found by Obrant in the very first solo audit we did. Okay, Vault Manager v2 burn DYAD function is missing and is the NFT only modified now usually burn on the minted DYAD. Again, the thought behind this was burning DYAD only increases your collateralization ratio, so if you want to burn your DYAD for someone else, go ahead, but it has some second order consequences, so burn DYAD is now only callable by the NFT owners. Okay. M8. Incorrect deployment missing contract will break functionality. The currency manager is the contract responsible for managing currency prices. Not really true. Not really true. In the current state, it has broken functionality due to design. The currency manager contract contains a list of vaults. The currency manager contract is expected to have a list of the banking vaults. This list is then queried. Crucially, the currency manager will not have the vault, which takes currency as the asset used for calculating asset price on a vault handling currency will make it go into an infinite loop. So this section of the code expects the currency manager contract to only contain a list of the vaults which has exo collateral. Now let's look at vault manager v2. Get currency value function. This function is supposed to return the value. Yeah, again, this is like an error of how we deal with this stuff. This is totally changed now. So in the deploy v2 we have a actually there is no okay inside the currency manager. The currency manager we add all the exo collateral. So that should be and okay, the way we do it now is a little bit different. We have these two functions, get vaults values, where we have this vault licenser, and this basically checks if a vault is licensed and if it holds currency. Okay, and now the value of currency can be manipulated to force liquidate users. Currency can be rotated from yeah. And a swap mechanism calculates the price of currency. Yeah. Well, that's currency. That's a currency mechanism. Instantaneously, yeah. Because the currency price is calculated on chain and not through a TWAP, but through a deterministic equation. Okay, low risk and non-critical issues. For this, all the tort reports are submitted by wardens detailing low risk and non-critical issues. CR could be undervalued due to its unsafe dependent on vault get. This function is used to get the price of an asset, and it gets that by creating the specific vault of that asset for its balance and price. Keep in mind that this function does not usually have a given price from the bounded vault as shown here. Going back to vault manager v2, we can see that the line is queried whenever there is a need to get the collection. Yes. Just to say the person requires to query chain link at the end of the calls. But evidently you can see that this call lacks any check on the in aggregator, which would make protocol easier Uber. Store the assets min-max check. Yeah, this is just a Oracle thing, guys. Like, yeah, we're getting our price from Oracle. If the Oracle breaks for whatever reason, then yeah, it's a problem. But even then, min-max would like I don't know. I don't like these checks, to be honest. Protocol does not enforce CR buffer in regards to user protection. We don't do anything to, like, it's your responsibility. However, when getting into a position for guidance, users have the position to be equal, which only then subtly breaks for the as user allowing liquidated with the next block. Because now we're not going to introduce a buffer logic. Yeah, if you do that, then you're immediately liquidatable. It is what it is. Volcat USD value should be routed in a try catch. Definitely not. Try catch is something I've never used until at the end. Very, very weird. Yeah, after Oracle fades. Well, we have some, like the multi-sig can remove a vault. But that's basically it. Grab the vault. Broker might overvalue asset transferred in by a user and unintentionally flaw their accounting logic. First would be key to know that process for different types of work, which includes even a flat fee. No. We're not gonna have any RCs that have a fee. Do not support these tokens, yeah. That's the plan. The currency plus can manipulate via donation attacks. You can also use in the bounded vault to get the asset price. The issue with the assumption of how the currency token was calculated within the TVS is by passing the balance of each vault's asset using the balance of function and then multiplying it by the vault's asset price. However, this method relies on the balance of function to retrieve the asset balance of each vault rather than using a storage variable that internally tracks vault. This opens up requiring a technical underneath an arbitrary amount of assets and vault. Yes. Hey, are you sure you're using the right mic? Sounds a bit off. Really? Yeah, I think so, man. Maybe because I'm too far away? GM. Maybe make it a little bit louder. GM. Is it better now? It's definitely using the right mic. Maybe yeah, I don't know. Let me know. Let me know if it's better or not. Otherwise, I can switch to my AirPod to my yeah, because no matter how far you were from the mic, it sounded the same. But okay, thanks. It is what it is, man. Okay. Wait. Let me actually. Yeah, because no matter how far you were from the mic, it sounded the same. But okay, thanks. Yeah, the sound is really bad. I agree. I'm sorry, man. The NFT owners can liquidate themselves. Yes, they can, but what's the point? You could hold two of the NFTs. Well, actually, you know what? Let's try out. You could hold two of the NFTs. Let's try out my other mic. Test. Is it better now? Let's try out my other mic. Let's see. Oh, I think that's better. Okay. Yeah. Nice. But yeah, thanks for pointing this out. So much better. Okay. That's good. Yeah, I'm a professional streamer. If you didn't, if you didn't know. For the whole reward vesting logic could unfairly make users liquidatable. We can see that the final price that's gotten for kerosene is dependent on this. However, this multi-sig value is not always going to be constant. That's to say, in case where there's a need to reward users for staking, they must send out tokens for the undergoing, however, can directly custom position that were narrowly float to become immediately liquidatable. Yeah, that's actually a good point. Yeah, it's true. It's definitely true. Because how we keep track of things. So I'm gonna show you. Let me write this down. Staking. We need to be careful when doing this. So we have this denominator function, which is called in the kerosene vault here, and the denominator is kerosene total supply minus the balance in the multisig. The balance in the multisig is most of the tokens minus some in the staking contract, or there's gonna be in the staking contract. So obviously this is gonna be less once we move out kerosene tokens from the multisig, which will have some effect on the price. So we will need to keep that in mind. The thing is, I'm not super happy with this logic. Obviously, it's kind of feels wrong, feels hard coded, feels weird to have this address that But if we think of a better mechanism, we can change out the kerosene denominator. So if we have a better mechanism that we can think of, would be nice to replace this. Update stale modifiers used in vault. Yeah, the modifier is used to know if a vault size is not stale. There's the introduction of kerosene vault logic, but these vaults do not have a modifier to license. Okay, let's see. Vault licensed because we're treating every collateral like any other. So kerosene is basically treated the same. So we don't have this issue anymore. We only have this vault licensor check now. Owner transfer actions done in a single step manner are dangerous. I know they are dangerous. Protocol might be incompatible with some to be integrated tokens into dependency on decimals. Yeah. We're not gonna add weird ERC20 tokens. Fixed documentation. Yeah, sometimes we use the term note. I never use this, to be honest with you. I know like our official name for the NFTs is note. I never use this. Maybe I should start using it. I always call it DNFTs because the contracts are called DNFTs, but DNFTs and nodes are equivalent. That documentation makes it harder to understand code. Very true. Very true. Protocol intends to have a duration between deposit and withdrawals, but instead hardcode sets to 0. What? Evidently, as hinted by the audit tag, you can see protocol intends to apply duration logic. After discussion with the sponsor, the check is placed so as to not allow customer. However, the check is not really sufficient, it doesn't have any waiting duration. What? Of course it does. has a 1 block waiting duration to avoid flash noise. And time between blocks are 15 seconds, right? 12. Okay, on average, 12. So yeah, Shaq can easily decide 12 seconds. That's true. No, we're not gonna add some arbitrary waiting duration, I think. Okay, I think that's it. That was fun. A lot of people looked at the code, which is always pretty cool to have people look at your code. I already fixed all of these issues while we were doing the audit, so we did a solo audit on the fixes. Then I did some refactoring. We're currently doing our last solo audit. And then I think we're ready for mainnet, which is exciting. So what did I wrote down? Medium 3. Should we make the vault upgradable? A minimum amount of deposit. What was medium 3 again? Medium. Yeah, any questions, guys? For those that are in here, any questions about DYAD, about smart contracts, about anything really, anything technical? M3 set unbounded casing. Oh yeah, this is not an issue. Okay. What was 12? Protocol intends to have a duration. Okay. Yeah, I think that's it. Hopefully we fixed all of these. I think we did. We're running the last solo audit right now. And then we're ready for prime time, I think. I feel good. I feel good about the contracts now. I think they're a pretty solid state. So yeah. Any last comments, questions? Put them in the chat. Now's the time. Anything about smart contracts, auditing. If not, then yeah, I actually wanted to talk about this, like upgradability. So we made the vault manager upgradable by the multisig. Hopefully we're gonna put some governance around that very soon TM. But yeah, in the past I was really a immutable maximalist. I'm not anymore, to be honest with you. Like if you're building wrapped-E, like I've put this out recently. I tweeted this out where I was like, okay, if you the only contract I would trust with all my net worth is wrapped-E, because it's auditable by anyone with basic Don't even need to understand Solidity, like basic programming skills. But yeah, if it gets just a little bit complex, especially in the beginning, like if you have a Lindy effect, you know, if you okay, this is live, this was live for a couple of months now. We thought of everything, not even like security-wise, but feature-wise. Like we basically upgraded from V1 to V2 because of the currency mechanism that we have now. And because we couldn't upgrade the vault manager, you know. This is something we didn't think about. We had the idea of kerosene. But we couldn't add it to the current system, so we had to basically redeploy everything, which I don't think is optimal because you have to move liquidity around and stuff like that, which sucks. So yeah, I think especially in the beginning, upgradability is fine for things that aren't complex. Obviously, maybe it's different if you're putting like there's some auditing competitions now for $1.5 million or something. You know, then it's different. You have like this 6-7 month auditing process. You're spending millions on auditing, and then you deploy it, and you thought of everything feature-wise. Then it's different if you're Uniswap or Eigenlayer or something. What's currently there's a very big one right now. What is it called? It's a protocol that got hacked and returned all the money. The borrow lending protocol. I forgot. But yeah, if you're something like that, then it's different. But yeah, we're at a different stage right now. So vault manager is upgradable, but that's the only thing. And hopefully we're gonna, you know, transfer ownership to the zero address or something, and then it's immutable. So yeah, hopefully. So this was the final draft that we just looked at. Once this is finalized, once we're done with our current solo audit, we are going to deploy this through our deployment script. This one. I think next week. So this is going to be exciting. All right, guys, then thanks for tuning in. And I see you in the next one.